So we're going to go to chapter 15. We're kind of jumping around, which is going to make doing the quizzes hard, but on the other hand, that's what the book is for. Reading while you're doing the quizzes, before or after. And so the question comes up, why in the world would you bother with all these interfaces, the concept of an interface? And the idea is that you can create a structure in which, a structured environment in which people contributing to it are all pretty confident that their stuff will work. And what do I mean by that? Well, say you're writing a user interface, and there's all sorts of things that could be on the screen. You can have buttons and checklists and sliders and this and that and the other. What you do is you define the interfaces that these things need to have in order to work. Every control item is going to need a way to get the value from it, right? Whether it's a text, you can read the text from it, or whether it's a slider, you can find its position or whatever. So you're going to define an interface that has a list of everything that a graphical user interface object needs in order to be put on the screen. Then you can publish that, and anybody else who wants to add graphical user interfaces, create their own or whatever in your team, right? You can all write to the same specification. It's a template. It's a template, and you say, okay, for this object to work, it has to have this, this, and this defined. And so that's the point of having an interface. One of the ways in which interfaces help is when we're trying to do what's known as object output files or object input files. That's a file where you can write out your object in one fell swoop rather than just writing out the name and then the age and then the height and the weight. That's 4 different pieces. You could write it out all with one call, and then you can read it all in one call. That's really cool. You can also do that with internet connectivity. You can do socket-to-socket communication and do the same thing. I'm going to send this socket to this remote machine, send that object to it and get it back. There's a couple drawbacks of doing it, but for the Java classes to be able to do that, your object has to implement an interface class. Now what's weird to me is that you add the implements interface keywords to it and then suddenly it starts working. You don't even have to add the code in particular. You don't have to modify your code once you do that. And I'm not sure why that works, how that works. What is it adding when we do that? That'd be worth a little bit more research. But let's first talk about exceptions. We know what exceptions are now. Exceptions are when you are things, problems, errors that are thrown, that are raised whenever something goes wrong that would otherwise crash your program. You divide by 0. You try to access an array element past the end of, passing into the array. You call .pop, but your stack is empty. That kind of stuff. You try to open a file and the file does not exist. So what you do is you have a try block, you have a catch block, and then underneath the catch block there can be a finally block. And the finally block is stuff that is performed regardless of whether there was an error or not. So for example, try this. Try to parse that integer and then catch the number format exception. Invalid quantity entered. It must be a whole number. So whatever we were trying to get in from the user, if it succeeds, great. If that statement works, it'll get to the next line. Well, there's nothing else here, and so it'll come down here and it'll execute the first statement after the try-catch block. That's where it's going to do its code right there next. But if it does encounter an error, it's going to jump into this code, into the catch. It's going to do that, and then it'll come down here, and it'll repeat from there. Well, what if you wanted to stop your program at that point? Well, there better be a return statement or something if you wanted to get, completely stopped out of it. So let's give an example of using try and catch to force some data entry to make sure that they enter an integer. Now, of course, our scanner class has, has nextInt and .nextInt, things like that to make it easy to read an integer. But instead, we're going to get an entire line of data with next line, and then we're going to convert it to an integer on our own. So we are going to need a scanner object. Different things will throw different exceptions, and there are hundreds upon hundreds of exception classes defined within the Java API just because there's a lot of different, parts of the Java API, each one that can fail in a different way, and they all need to be distinguished from each other. And so you could have multiple catch statements all chained in a row. And if they don't get triggered, if the code succeeds, then none of them will activate. But if an exception is thrown, it'll jump into the catch that is appropriate, just kind of like a switch case. It'll jump to which one it needs. So for the semantics for the previous slide's try and catch code, it's tried to convert it using integer.parseInt. So if the user enter string contains all digits, then the int version of user entry is assigned a quantity. In other words, it succeeds. This call succeeds. I don't know why they're saying it in such a difficult way. Right. You pass that in to that function, and it returned an integer, which we can store there, thanks to the helper class there. But if the user enter string does not contain all digits, I cannot believe I said digits, then the parseInt method will throw this particular exception. And if we go and look at the Java docs, it explicitly calls out what exceptions it can throw. And that's probably the only one. That's probably enough. We could go look, though. We could go and find, the documentation for integer.parseInt and see if it throws any other exceptions. Well, that's one of them. The number format is wrong. You put in a period. You typed in some letters. And so then JVM looks to see if we're in a try block. If we are, it looks to see if there's a catch block that is defined to catch that specific exception, a number format exception. If there is, it'll jump in there. If not, but a exception had been generated, but there's no catch block that matches the type of exception, then the program crashes. And we're going to try to avoid that. Remind me what lecture we're on. N as in Nancy. Michael. M as in Mancy. That's right. All right. Here we go. So we're definitely going to need a scanner because I want to use next line to get our input. And I think we've talked about this maybe in the past, that if you start mixing calls to .next and next line, then it can get confused. And so if you're going to start using next line, you pretty much need to use next line throughout the entire thing. But on the other hand, it's also a good idea just to know how to convert from strings to integers anyways, because if you're pulling data from the web, it's most likely to come into you as a string. If you're letting the user type in something, it's most likely to come into you as a string. All of the user interface libraries return strings for you. If the user types in the zip code, too bad, it's a string. It'll be up to you to turn it into a number. So we need a scanner. Add the import for it. All right. So to try to do some defensive programming, we're going to make sure that what they type in is actually a number, meaning that once we try to do the conversion, it had better work. And if not, we're going to loop and require them to do it again. Pardon? 520.
It's forever now?
Yeah. But don't worry, you can always come back. And we just started typing code, so you've timed it perfectly. So don't sweat. Good work on the exam, by the way. So here we go. We have our scanner here. And there's always a million different ways you can write a loop. I'm trying to decide whether to subject y'all to a while true loop. Let's do this. Boolean valid equals false. And then while parentheses exclamation point valid, while not valid. Let's tell them to type in something and then let's read it. System.out.println, enter a number. Now I'm going to need a variable to hold my result too, and I should have declared that outside of the while loop. So Let's go ahead and what is our variable going to be? I don't know, but let's make it a double. Or an int. Why not? Int I. Very good variable name. Tells us a lot about it. So now let's read our data. We need a string because we're just going to call .next line. String s equals sc.next line. Now we have some data. We're going to try to parse it. And this is the part that's going to blow up if they've made a mistake in the way that they formatted their data. If they typed in a decimal point or entered a J or, whatever. So I equals, capital I, integer dot parse int, parentheses s, in parentheses. And if that succeeds, great, everything's perfect. And we set valid equal to true, so it'll exit the while loop. Now, here I am real proud of my class, right? It's not going to work. It's not going to handle bad data because I haven't put anything in a try-catch block yet. Enter number, 9. Okay, cool, it worked. Enter number, 9p. And it blows up with an exception, which is not what we want to see. So this chunk of code right here is the dangerous one. That's the one that can crash. I think just for ease, I'm going to put all 4 of these lines in a try block. So try, and I'm going to have to cut a curly brace and put a curly brace back in and tab, and so you're going to have to be real careful about your curly braces and stuff like that. So to make that easier to follow, I'm going to add some comments. This is the end of the while. This is the end of main. And if we felt so inspired, we could say that this is the end of the class, which makes that the end of the try. And why is it yelling? Because we have a try with no catches. All right, so catch. What kind of exception will it catch? Well, if you don't know what kind of exception it's going to catch, you could just say catch any exception. Now this is considered really, really, really poor programming. Yeah, just catch anything. We ought to only catch the specific exceptions that we think it's going to throw, because if it throws something that we're not expecting, that's big news, and we really need to know about it. So if we just say, okay, catch any possible exception that could ever be generated, then we're not going to find out about this unusual circumstances. So we need to find out what parse int can throw. Now if I had kept my output window open from the last one, I would see it. It's a number format exception. If I didn't remember, I could do show Java doc. It would pop up and it would tell me which exception it throws. Number format exception. So let's do that. The catch statement is going to look like this. Catch, parentheses, number format exception, EX. And we just need to tell them what they did wrong. System.out.println. Data must be a whole number. Something to that effect. Don't break your code up like this. I'm just doing it because I want it all on one screen. That should work. Enter a number. Data must be a whole number. Well, that didn't tell us that it had non-numeric data in it, right? But still, it's enough to prove the point that until they give us a good piece of data, it's not going to exit the while loop. So the homework involves doing exactly what we just demonstrated. letting the user type in something and we convert it to an int, but if they type in something wrong, we need to tell them. And then it also checks to see if something will crash when we do the division. And if we try to divide by 0, it will in fact crash. And let's just prove that to ourselves by going back to our code and putting a simple divide by 0 thing in a try-catch block. Right. Try this. Try this on for size. System.out.println 1 divided by 0. If I had commented at try out, and if I'd commented at closing block out, we would see that this does generate an exception. Right. And there's the error. Arithmetic exception. So in order to catch that specific error, I can do so. I can do catch, arithmetic exception. So I'm going to modify my code to do that. Catch, parentheses, arithmetic exception. And I'm going to put a comment here that this is most likely a divide by 0, probably. You can query the exception object for information about it. So let's system.out.println ex.get not just toString, get message. That's the one I want. So system.out.println parentheses ex.get message, open parentheses, close parentheses, one more close parentheses. So we're just going to see what message that is when it tries to divide by 0. And since this is all hard-coded, there's no way for it not to divide by 0. So I'm definitely going to see that message, no matter what we type in here. All right, and there's our cute little error, divide by 0. It'd be cute if it's cuter if it said error in front of it, right? It doesn't, so maybe we will put error colon, right? Error colon space end quote plus, something like that. There. Not very elegant. Now the finally keyword. The finally keyword is something that happens whether or not the exception occurs. To demonstrate that, are we done here or do I need to slow down and let people catch up on typing? I hear fingers going, so I think I better slow down. We all good? Okay, so to demonstrate the next thing, I'm going to make a different class member. Public static void divide me. It takes two numbers, int x and int y. How about we just call it invert, so that we pass in a number and we try to calculate its inverse. So invert, reciprocal, something like that. Okay. And so here's what we want to do is return 1 divided by x. Except I made it a void, so obviously that's not going to work. Change that void to int. But we know now that dividing by 0 can be a problem. So why don't we declare a variable called result and then do try. Now we don't even need to do that. I took that declaration off. I'm just going to try, and the division is going to be 1 divided by x, return 1 divided by x, and then the catch is going to be that arithmetic exception. Catch parentheses, arithmetic. Remind me, is it exception or error? Exception. Okay. Arithmetic exception. System.out.println. Oops. Can't reciprocate a 0. Can't div by 0, whatever. And in that case, it's just going to return a 0. We're going to pretend in this word that the reciprocal of 0 is 0. Now this particular code has no need at all for a finally clause because these are doing one thing or another. But say that we had opened a file up here in order to read our data, and then we wanted to make sure that the file got closed regardless of whether it was going to return with valid data or whether it was going to return our error code here. Well, that's what finally is for. In the finally block, you put code that has to execute regardless of whether it is successful or not. In this case, let's just print out some kind of message. Finally, ... So that's my function. Now what's weird about finally, or at least unsettling to me, is that if this tries and this throws an exception, yeah, that exception will be caught. And now it's trying to return out of the method, but before it can, it jumps into the finally code and does that. The finally code is guaranteed to be executed, regardless of whether there's a break, whether there's a return. No matter what, it's going to run the finally code, regardless of whether it succeeds. It does this, and it goes, okay, now I'm returning, but nope, before I return, I got to do that finally block. And then it comes back and it gracefully returns. Or if an error occurs, it goes ahead and prints that message, and as soon as it starts returning, it goes, nope, I better execute the finally block. It does it, and then it comes back and it returns a 0. So let's call our invert functions 2 times inside of main. Invert 1, that'll be successful. Invert 0, that will not be. Now this is not going to kick out any error messages or actually any positive output whatsoever, right? Because there were no print statements on a success, only upon failure in the finally block. So maybe we ought to print those 2 things out, right? System.out.println, but I think that we could demonstrate it with the debugger just as well. So I'm going to click on the breakpoint there. I'm going to start my debugging. It ran to that point. Now I'm going to step in to the invert method. So I'm going to find the little block that says step into. Now I'm here. It's about to execute this. X is equal to 1, so it's not going to be an error. So when I do step over, great. Well, but it wasn't able to return yet because there's a finally clause. It had to run down here and do that first. And it did. If we found our output window, then we would see that it had printed out what we wanted it to print, wherever my output window is. Right. And so now we're back out of it, and it's ready to go to the next line. And so now, I believe we're on the next one. And so if I do step into...
Professor?
Yes, sir.
Yeah, I just turned
Aha, sorry.
So I was waiting for you to get done with this.
Okay.
So I'm not sure
Yeah,
if
so
you answered the
let
question
me
or not.
demonstrate it failing, and then I'll go over there. Thanks. All right, so the second call, we're in here, but x is equal to 0. So when I do a step over, this line was unable to succeed because dividing by 0 caused the arithmetic exception. So it jumped here. It's going to print out our error message. Now it's going to try to return, but before it can return, it has to execute the finally clause. And now it can succeed the returning. I don't know if you saw it, but the green line was here, and then when I clicked to go to the next line, it went ahead and went back there because now it's ready to return. And now we're done with that. Yeah, the output's not going to be terribly interesting because we didn't print the results of our calculations. But here's what we got. The first one did print finally because it had to, but it succeeded, so it didn't print an error message. The second one did print an error message and it print finally. So in both cases, finally was produced.
I was just trying to make sure that I had the right thing.
You got it?
Yeah.
Is it working? Okay. Good for everybody? Remove my breakpoint.
Sometimes we use divide by zero to jump out of a program for other reasons. I mean, we force the.
It forces it to append on you.
To append.
Yeah. So number format exception can be thrown by any of the parse methods. Parse int, parse long, parse double, whatever. There are, broadly speaking, two categories of exceptions. There are checked exceptions and unchecked exceptions. Checked exceptions are ones that have to be caught or the code won't even compile. If the developers of Java had decided that parse int was such a dangerous thing to try to do that you'd better put a try-catch around it, then they would have made it a checked exception. They would have made number format exception a checked exception. It's mandatory. If you think of the word checked as meaning mandatory, then yeah, we would have to. But we don't have to, because it is a unchecked exception. You don't have to check it. It's a good idea, right? If there's any chance that it's going to fail, there's a good idea. But it's an option. File I/O and I/O over sockets and stuff like that have mandatory exceptions, checked exceptions. So they come from a different block. This is the hierarchy chart for the exception. The exception class. There is a category of exceptions called runtime exceptions, which are unchecked exceptions, and everything that's an unchecked exception inherits from runtime exception. And then everything else inherits from checked exceptions. And then there's a third category called error. I'm not sure why error is not a child of exception, but again, it's an unchecked exception. So if the code needs to handle an unchecked exception, you put the try and the catch there block yourself. If it absolutely is mandatory, you'll find out the compiler will not work, like we saw when we were implementing our file I/O last week. So deciding on the size of your try blocks is a bit of an art. Sometimes you might want to use a whole bunch of little try blocks. Sometimes you might just want to slap a great big try block, right, and enclose a bunch of code in it. Note that it's legal to surround an entire method body. We could put try up at the very top of main and catch at the very bottom of main. It's legal, but usually counterproductive. It makes it harder to identify dangerous code. In general, you should make your try block small so that your dangerous code is more obvious. You want stuff to fail if a problem comes up that you weren't planning for. That sounds dumb, but you try to catch all the problems that you could foresee. But if something new and unusual is going to happen, then you actually want note of that, and putting just a try-catch with an exception, generic exception handler would cause that. So if a chunk of code has several dangerous methods, you could add a separate try-catch structure for each call, but that might give you cluttered code. Or you might use a single try block with several different catches. And that tends to be what we do when we're doing our file I/O, because file I/O might generate more than one exception, but it's convenient to put all the code that does that file I/O in one block and then just have several different catches for the problems that can result. I like this. The compiler is a pessimist. It knows that statements inside a try block might be skipped and assumes the worst. Consequently, if there's a try block that contains an assignment for X, the compiler assumes that that assignment is skipped. What does that mean? What if we have this code? Don't necessarily modify your code to do this. This is just to amplify their point. Here we had a divide by 0, right? But what if we had some variable, int something, and then here we change the value of something to something else? Down here, if we tried to use that value, the compiler would tell us that we couldn't because it's possibly uninitialized. It'll be initialized some of the time, but if we get an error, then it won't be initialized. So if I try to do int y is equal to sum, something like that, that's an error because sum may have been initialized, but it may not have been. And so the compiler's a pessimist. It assumes that since there's a chance that it won't happen, that it won't be there at all. And so initialize your variable. That would be the fix for it. We could give it initial variable value, and that would fix the problem, right? So it's something, but then later on we set it equal to something else. I don't see any reason to leave that in the code, though. You can create your own exception. If you're writing some code and you want to make the people who use your code, other programmers working on the project, use it correctly, then you may implement a checked exception and implement your own exception class, give it your own name, and then they have to go ahead and they have to use the code in a way that you are requiring them to do so. So if a code fragment has the potential of throwing a checked exception, the compiler requires that there be a try-catch block with a catch associated with it. Create file, in this case, is something that could throw an exception, and if it does, it's going to be a checked exception. So this will not compile. What is files? I'm not really familiar with the java.nio library. I'm going to leave that one alone. So this is all interesting, but I would rather actually do our examples with the kind of file handling that we do in the next chapter. This is telling us how to access a path to see if a file exists or not. And we have a lecture based on that, but I don't want to do that right now. Alright, so here we have a program which is supposed to read from a file and print out all the lines in it. So they declare a scanner from system.in, probably so we can ask for the file name. We get the file name from the scanner. We create a new file, a new scanner using the file name. But if that file name does not exist, that's going to crash. So that's why they have this in a try-catch block. And this code would work just as well if you passed in. No, I guess I'm okay with the way that they've structured that, but I prefer the way that we did it last week. And then while the file has any more data in it, we print it out. You can catch more than one exception for a try block. Here's an example. If we think that that code is either going to generate an invalid path exception or a no such file exception, we will not have to put two catches, one after the other, in order to do it. That little vertical bar means, oh, this variable might be that or it might be that. Just treat them the same way either way. And then they did put a catch-all here so that any other errors would also be caught. And they'd get the name of the exception from the object so that they could print it out. Right, print a message because it's an unexpected error we weren't expecting for it, so we put a handler for it. I'm going to go back to the file I/O stuff. I think that this just goes in longer and longer explanation of the same kind of stuff. Adding exception handling to code in order to get this to work. And we already have the idea now. So here's another error that could pop up, the array index out of bounds exception. If you try to access element number 10 out of a 5 array, then it would throw that. And the finally block. You put stuff in the finally block that needs to occur regardless or not. If a file needs to be closed, then you can put that in the finally block. Whatever kind of cleanup you need to do. Here we're using a print writer to try to create a file to save some text to. And it's funny how much file I/O examples they're putting into the chapter that comes before the file I/O chapter. Because this is 15 and then file handling is in 16. But the two are so intimately tied together that all their examples seem to be about file I/O. Well, anyways, we're trying to open that file. But they don't have a catch here. So they better have a catch at the top. What? Well, this code will not compile. There's no catch. Oh. If you do not feel obliged to handle the exception in that chunk of code, in that method, you can add a clause to your method header saying, oh, by the way, if we get an I/O exception, we're just going to throw it. And it's up to the calling code. And you'll see that when we hover our cursor over the error message and it says, you know, such and such file not found, error not caught, must be handled or thrown. Well, by putting the throw keyword there, the method is saying, oh, we might throw that exception. And that's enough to make the compiler happy. If that error does occur, then it'll let that method go ahead and throw the exception back to the calling code, the client code. So let's go to chapter 16 and play more with writing files. I always forgot how annoyed I get at the fact that this chapter goes into buffered reads and writes more than just demonstrating the simple reading and writing of binary data. But this does lead us directly to talking about the serializable interface, which is what you have to implement in order to get object output files and object input files to work. Just just a minute. So for a large file or remote file, something you're reading over the internet, you should always use an intermediate buffer. A buffer is a sequential storage structure that acts like a first in, first out. Since the buffer resides in high-speed memory, during the program execution, the program can transfer data into or out of the buffer much more quickly than it can out of the file that it's reading or writing to. So the following buffered write-to-file program shows how to write text to the buffer. So the file has a class method. When we're creating our new buffered writer, we need to feed it a path. We need to feed it a character set and all the open options. And we know that it can throw an I/O exception. Their example, though, does not necessarily have us digging in deep in all those things, because if we look, here is how they're creating their new buffered writer. All they're doing is passing it a file name. They're not setting the character set and those other options that we see that it could require. So the default values are working okay. No, I'm wrong. Char set, default char set is right there. Standard open option create. Standard open option value of. Get that? Okay. And so that's considerably more. This is the way you would do it if you were going to read in a large amount of data. I don't think it's the clearest way of doing it, and sometimes I prefer clarity of examples over the complexity of the examples. Well, since I didn't prepare that file, I thought I had it in the PowerPoints, and I don't see it. Then we might demonstrate with the print writer again and the scanner for doing the text input and the output. I just want to play for uno momento. I'm going to come up here to the top of main. You don't have to do this, but I'm going to try creating a file. File F equals new file. Like that. It's going to tell me it doesn't know what a file is. So I'm going to add the import for java.io.file. And it's going to still complain because it doesn't have the right constructor arguments. So then show javadoc. You're not going to show the javadoc, are you? There we go. So the options you can pass to the constructor is you can give it a string, which is a path name, or you can give it some more complicated options, a string child, a child path name string. Well, that's interesting. Once we have created our file, then what can we do with it? Well, this did not specify whether it was a file for reading or for writing, and that's okay. It's just creating a file object, which we're then going to use. I'm just going to call this one test.txt. Even if it doesn't wind up being a txt file, at least we'll be able to find it pretty easily by doing a search for test.txt on our operating system. So if we have that file object, if I type f dot, lots of methods we could play with it. We want to convert it to a path to use with the path object. We could do that. We could check to see if it's a directory. We could check to see if it's a file. We could check to see if it's hidden. Well, I don't know how we can do all that if we're not absolutely sure it's there, but why not? Let's check to see if that file already exists. So I'm going to call .isFile and just find out if it exists. Or, no, I'm going to call getPath and see what it has to say about that. So, does getPath require creating a path object in order? No, it'll just store it in a string. Okay. So, string path equals f dot get path, parentheses in parentheses, and let's print that out. System.out.println, parentheses path. And good enough. That's the path to it. We could get out more interesting information once we actually start doing something with it. So let's create a print writer so that we can write to that file. Print writer PW. PW equals new print writer, parentheses, and we're going to pass in our file. It doesn't know what a print writer is, so I need to add the import for that. And now it's complaining that it has an unreported exception, the file not found. So just like we did last week, we're going to wind up putting this code inside tries and catches. We just have to decide how much we feel like putting it in there. I think I'm going to go ahead and maybe just enclose the whole shebang in a try-catch block. I was wrestling with that, and I think I'll go with my instinct, and since you mentioned it, yours. Okay, so I moved print writer back out there. I was temporarily considering doing all of the writing with it right there, but okay, so if that works, great. If not, we're going to get an error and we have to catch it. But then the question becomes, how do we handle the rest of the case? Are we just going to return out of it if it doesn't work, or what? So let's add our catch. And our particular catch for this is file not found exception. So catch parentheses file not found exception EX. System.out.println file not found. And yes, we should have asked for the file name right, but we're just hard coding it to test.txt. Now it doesn't know what that is. Okay, so fine. Add the import for java.io.filenotfound. If I just clicked on the error and let it did a add catch for it, then that would have worked great. It would have added the import for me as well. Okay, so the problem is that once we are here, we really don't know whether the file is open or not. So that's why I was considering sticking all of the code inside the try block and then just running with it. But we could initialize this to null, and as long as it's not equal to null, we could do if print writer not equal to null, then start using it. But I'm going to go ahead and put it all inside the try block. And so say we have a class that contains 3 pieces of data. I really don't want to go on to this too much when I also want to be talking about dictionaries. Okay, but anyways, so class point. Last time I used point, we started getting into arguments with the compiler because there is an existing class, so I'm going to call it pPoint. And it's just got an int, an x, and a y, and a z value. So let's create a point and then write it to our file. Realistically, I would do this above the try, but pPoint P1 equals new pPoint P1.x equals 10 P1.y equals 20 P1.z equals 30. we have our print writer open now. I typed in a lowercase p there and it should have been uppercase. And so I'm going to write those three values out to the file. So pw.print line p1.x, and then the same for p1.y and p1.z. We could make another point and write it out the same way. Let's just write these options, these values out again, simulate the fact that we have a second point that we're adding to it. So now when we run this, it's going to produce a text.txt file that's going to have 6 lines of data in it. X, Y, and Z for one point, and an X, Y, and Z for the other. And if we get to this point, then we would want to close the file. However, if we use this syntax, try, and then we enclose the definition of the print writer right there, then it will close the file as soon as it's done, regardless of whether they're another example, another day. pw.close, just to close the file. Okay, so we have our file. Now we might want to open the file and pull those points of it out, those points out. So we're going to open it with a scanner. So file fn equals new file. Let's pat that path in again. Test.txt. End quote in parentheses semicolon. I think I will do this one with the try with resource because then we just won't have to cancel. We just won't have to close it in. The syntax for it is you put parentheses after your try keyword, and then you create the object here that you want closed and removed inside there. So we could have done try parentheses print writer pw equals and then so on. But anyways, try parentheses scanner fin FSC for file scanner equals new scanner parentheses fin in parentheses and it's complaining about the exceptions. We don't have the exception handler for it. The exception is file not found. Again, to save time, I could just copy this one. And again, it's really lame that I did not store the file name in a variable so that I could print it out along with my error message. So I'm just going to put text.txt file not found, right? Just because I want some kind of hint that it worked. All right, now we need some kind of loop that's going to read that data from the file. And I don't recall the error that is thrown by trying to read past the end of the file. Since it's a scanner, we could just use has next, right? As long as we have any kind of data. Since we're using a scanner, we may as well take advantage of its functions. So while fsc.has next, while it has any data, we're going to keep repeating. we need to read in those 3 ints and create a point object based on them. So point P2 equals new point, parentheses in parentheses. Excuse me, it was called P point. P point P2 is equal to new P point. And let's read in those 3 pieces. P2.x equals fsc.nextInt. And then make P2.y and P2.z work exactly the same way. P2.y equals fsc.nextInt, parentheses in parentheses, and P2.z equals fsc.nextInt, parentheses in parentheses. And then we may as well print that out. System.out.printf point %d, 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 \n, end quote, comma, p2.x, comma, p2.y, comma, p2.z. Now we could go ahead and close the scanner. We could call fsc.close, but since we did this try with resources thing, it's going to get closed automatically anyways. And just so we can tell where we're at, I'm going to add one more print here at the end of the while. Done reading from file. So hopefully the file exists because we just wrote to it a minute ago. And so it did find the 2 points that were stored in that file. And yeah, they have duplicate data, but you know why. It's because we wrote, right, the same point out twice. So to recreate this point, we had to create a point object, and then we had to fill in each individual point with a separate read to the file. And it is really cool if we can write the object out, or we can read the object in one fell swoop using an object output file. So to do that, you create an object output stream, and then you create a new object output stream based on the new file output stream. And I don't usually nest my declarations like that. I normally do them that one first and then that one. Let's give that a try. And then we're going to create a point, and we're going to try to write it out with one call rather than writing out each individual point, which would get tedious if it was a complex object with hundreds of members. So the above were examples of text file I/O using PrintWriter and Scanner. Now for object I/O. Let's create a new file object. I'm not going to use the same file name because it is not formatted correctly to be read from at all. So file fnew equals new file. And let's actually do this properly. Let's give a variable name that'll hold our file name. String fname equals quote. Let's call it object.txt so that we can double click on it with Notepad, but it's not going to look like data at all. We're not going to be able to open it that way, really. We're not going to see any valid data in it. And so file fnew equals new file fname. That. So file input stream FIS equals new file input stream parentheses F new based on our file. And it doesn't know what a file input stream is, so we're going to add the import for it. It's still going to complain because it doesn't know. I mean, we haven't added the try catch for the. We will do that promptly. After this, we're going to create the object input stream so that we can read in from it or write out to it. It's actually an output stream. My mistake. Change the word input to output. We don't have the file to read yet, so we have to write it out first. So file output stream equals new file output stream. I apologize for that error. Better add the import for that as well. And now we're going to create the object output stream that uses FIS as its constructor. Object output stream, parentheses OOS. Wait, no parentheses there. Object output stream, OOS, equals new object output stream, parentheses FIS, passing in FIS as our argument to the constructor. We better go ahead and add our try and catch so that everything will stop being underlined. We do need to add the import for, we could have just done import java.io.asterisk and gotten all this good stuff. Might have been a good idea. It's complaining that we don't have catchers. So let's put try in front of that one. Now since I don't use try with resources very often, I don't know if you can create two separate objects like this inside of one try with resources. Yeah, I know how you could do it. You could use that nested new syntax where you create an anonymous object and pass it in. Alright, so there's my try block, and I'm going to let it fix it for me. I'm going to click on the error and say add a catch clause for the file not found exception. And that didn't fix everything. There's another one there. Add a catch clause for java.io.exception. Now the textbook showed a cool way of writing one exception handler that would catch both types of errors. And if I modify my code appropriately, I can get that to work. I'm going to cut this declaration right here, that IO exception declaration. I'm going to cut it. I'm going to paste it into the first catcher and then follow it with a single vertical line. And then I can delete the rest of this catch. Maybe I shouldn't have. I'm getting errors here. Alright, undo, undo, undo. Yeah, I was trying to be clever. There. Alright, so I've left it the way it is. I haven't even implemented good error messages. Right, I would want to go ahead and add in good error messages rather than using the logger class to handle them for me. Alright, we have some objects. Or no, we don't have any objects, but we have, let's create 2 points and write them out. See, if we'd made a constructor, it would be so easy to make these points, right? Point PA equals new point. Excuse me, it is P point, I keep forgetting that. P point PA is equal to new P point. P point PB equals new P point. And just so we have some differences between them, I'm going to set PA.x equal to 3 and PB.y equals to 4. Right? So we have some difference between the two objects we are about to write out. I should stop at this point because if you've had syntax errors, we probably have run past you. A file not found exception is a subcategory of IO exception. So that one is not strictly necessary. I could delete that one and it would still work. But maybe I like having the 2 errors, but half of y'all aren't seeing the 2 different catches. So since this one can handle both of them, great, why not? But I am going to change that to something slightly more generic. system.out.println error writing to end quote plus fname. Right.
So getting rid of that logger, get logger thing.
Right, all I did is delete the logger.getLogger stuff. All right, now I haven't written the objects out. I created 2 new objects, but I haven't written them out. So we're going to write them out. Our object output stream is called OOS. And really I should have called this FOS, right? Because it's a output stream. I know I'm going to break somebody's code if I do this, but it's bugging me where it says FIS. Change that to FOS, but then you're going to also have to change the argument that was passed into the next constructor. All right, so let's write those objects out to our object output stream. OOS dot write object. OOS dot write object with a capital O, parentheses PA, and then do the same thing. PB. And then let's close the file. So OOS.close, parentheses and parentheses. So if I go and find that file name, object.txt, wherever she may be, she'll be in the NetBeans directory. And that's what we're seeing. Okay, now honestly I was expecting to have to add something to our class to get it to work this way, to be able to read and write it as an object. Here's what I thought we were going to have to do, and I'm just surprised as all get out that I didn't. I thought I was going to have to come back up to the class P point and do implements serializable. And serializable is another class that we'd have to add an import for.
Well, I'm getting an error related to that.
Oh, when you try to run it, does it
Yeah.
crash?
Yeah, it says java.io.not serializable exception for people.
Yeah. So for this object to work, this class to work with object output stream and object input stream, we should have had to make it serializable. And that's what you're seeing.
Yep.
Okay. Okay. Yeah.
I've screwed up again. It's loot, I can't find this OOS.
Put all of that for the catch. All that stuff needs to be cut and pasted to there. Now, I think I mentioned that this is what I find is odd, is that what you use interfaces for is to require the programmer to come in and add something to their code. So why just adding that in there, not adding anything to the code? Why is that enough to get this to compile and run? I do not know.
So what was this? Was this OOS?
That name. Let me bring the code back. But I also want to make sure that add that implement serializable up in your class definition. So. That was something called add the import for me.
Oh.
Let's go back. Okay, so when I run it, it did write the stuff out to the file, I expect. I did not put a print message that said file successfully written, which I should have. Down here, after we print out our two objects, after my oos.close, I think I will add a system.out.println points, p points, written to, end quote, plus fname. So let's try to read those objects. So
My run button's not on, it looks like yours isn't either.
and that's because it's currently running. If you have a version of it running, sometimes the run button becomes disabled.
Oh,
And so down here, that little X where it says lecture run, I could kill it that way. Or I could probably find my output window and kill it there, but this is the fastest way in my mind. Did that get it for you?
yeah.
Okay, good point. Okay, so here it's offering to convert this to a try with resources. I'm going to go ahead and do that temporarily, and now we have nested tries. I'm not real impressed with that. If I had wanted to, I could do this. Don't make this change. I could have cut that and used that as the argument for that constructor. And then I could have put this inside that, right? So that it would create that file, and then it would close it, clean it. We would not have to. Now that's a lot to go through just to remove the, the oos.close at the end. So I'm going to undo those changes. But you can create an anonymous object, which is doing the new without putting it in a name, and then passing it in right there. So instead of FOS there, it could have been new file output stream. And I've seen Elaine do a lot of that in her homework. All right. Okay, so we're going to open that file for reading now. So, file fnew, coming up with bad file names. How about in file? File, we could have changed the other one to out file. File in file equals new file, parentheses fname. And we know we're going to need a try catch block, so why not just start it all off already? And so file input stream FIS equals new file input stream, passing in file as its argument. And now let's create the object input stream based on that file input stream. Now object input streams are cool because they can use other sources of input other than just files, socket connectivity. Object input stream, OIS equals new, object input stream, passing FIS in to its constructor. And now it's complaining. And we've learned this time that if we handle we have to add our imports first. If we add a catch clause for Java IO exception, then we don't have to add one for file not found. So I'm just going to do that one. I'm going to click on the bottom error and do add catch clause for IO exception. And I'm just going to change that one to a print as well. System.out.println, error reading from plus fname. And honestly, I've forgotten how you prevent this from trying to read past end of file. The PowerPoint may tell me something of interest. Wow, learn from the book. Let's take a look. But otherwise, I'm just going to write the loop, let it run until it generates an exception, and then add support for that exception. Yeah, that's what I'm going to do. So let's just put this in a while true loop. We're just going to keep reading from the file forever. See what happens. Okay, so what are we going to do? We're going to make a point reference. No, we're not. Yeah, why not? Point P equals parentheses, and it's a P point, excuse me. Forget that. P point, P equals parentheses, P point in parentheses. We're casting this because what this method returns is an object, just a generic object type, and we have to cast it to the type that we know what we want to do with it. OIS dot read object. And we have another exception that we'll have to handle. Unreported exception class not found. So that's the error that read object can throw, is that it did not know what it was trying to read. What we told it to read did not match any classes that had been defined in this file. So we're going to have another catch to put there. But let's go ahead and add our print statement first. System.out.print line just read point end quote. Nah. System.out.printf read %d \n end quote comma p.x comma p.y comma p.z. And now I'm going to get around to adding the catch. Add the catch clause. And so we have a new catch down here for class not found exception. And I think I'm not going to even customize that one. All right, I'm going to run it and see what happens with it in that loop where it's trying to read infinitely from the object input stream. We did get an error reading from object.txt. I don't know what kind of error it is, probably because I removed that logger command, right? That would have given me a more specific error message. All right, a little bit of Google never hurt anyone. EOF exception, that's the one that I want. So we're going to add an exception handler for EOF exception that just means that it hit the end of the file. Now this is a crude way of doing it. I'm sure that there's a better way that won't use exception handling just to note that it got to the end of the file. But for now, I don't mind doing it. I'm going to put it here because it is a inherited version of IO exception, and so if I put it underneath, then it wouldn't be able to pick it up. So catch EOF exception EX. And it doesn't know what that is, so I'm going to add the import for it. And why don't we just put out system.out.println reached into file. I'm going to add a comment here to my while true. Keep reading forever. This will throw an EOF exception when we hit the end of the file. somewhat adventurous. Google up the correct, or read from the book, the correct way of handling this without relying upon the end of file exception being thrown. There ought to be a function that we could use to break out of the while loop to stop it. What the heck? Maybe it's just a method. Maybe there's a OIS dot nope, I'm not seeing it. I wanted to see something like is empty, right? Or is not empty. Not seeing it. Okay. Anyways, now when we run it, it should print out reached into file when it gets there, after it's read our points. And so we have written code that reads objects in and writes objects out two ways. One is to a text file where every member of your object has to be written out, and then every member has to be written back in, read back in. Or the other is where you do it in one swoop. Now what's the bad thing about doing the one swoop idea? The bad thing is if the format of the class changes, right? I have a file called object.txt, but then I go and I add I modify the point class. I add a constructor to it. I add a new, member to it. That old object.txt file is now no longer compatible with it, and there's really hardly any way to fix it. So you wind up writing extraordinarily annoying code where you have different versions of the classes, and you try to open and read it with this version, and then okay, and then you try to open and read it with a different version, and so on. So it's awfully convenient to be able to write an entire object out and then read the entire object in, but if you're going to try to establish some legacy data, and it's possible that the class is going to change, then it would not be the wisest way to go. It's just awfully convenient. It's awfully convenient because you can send it down to a socket with one command, you can read from the socket with one command, and that the object can be extraordinarily complex, and it will just magically reconstitute itself as long as it has that inner implements serializable on it. Do I need to look at anybody's screen? Anybody? No braces? No bracers? Yes, ma'am.
I have an error. I'm just curious. Is that what we're supposed to print out for the objects?
Right. It looks like garbage, doesn't it? Okay, so if we go and we look at that file that it created, not real fun. It's not ASCII data, it's not text, so we can't really see what it's doing. All that we can tell is that there's a class called lecture m.ppoints, which is what it's using. And when it's trying to reconstitute the data in the form of an object, it uses that information to check to make sure, that that's what it is. And then the rest of it, there's no way we could read. Let's put that file into hexed.it, and we'll look at the binary data for it, if I can find it quickly enough. It's an object, my documents, NetBeans projects, okay. Very little data, really. But each point is only 3 integers long, right? And so as part of our data, we did set our point values equal to, like, what were they? One had a value of 3 and another had a value of 4. So if we're looking in this output, we will probably see a 0, 3 there. That's the point, the member. And then we will see a 0, 4 that represents another point. Yeah, so it's binary data. It's nothing that we can manipulate with any of our editors. But we could change that. If we wanted to, we could go in and hexadecimally edit that, save it, and read it back into the file. And if we change that to a 10 or something like that, then that object's X value would be changed to 10. Alrighty. Any other questions? No one's meeting my eye. You are. Thank you. I appreciate that. Okay, so let's look to see. We had homework queued up regarding exception handling. So that's homework 15, and we've already demonstrated everything you need to do for that one. That's the one that you just have to make sure that they type in good integer data, so you have to catch that exception and catch the divide by zero exception. And then we will have the print writer and scanner homework. Which hopefully is not overly evil, because I want y'all to have time to work on your projects as well. Oh, and I even put some tutorials in here. Alright, you don't have to watch the tutorials. If you want to, we have. Okay. So, our program should loop. As it runs, it should do the following. Ask the user whether they want to create or read the file, and then prompt for the file name. If the choice is to create, ask the user for a message string and its priority. Store that information in a JMessage object, which is just a class you'll write, which accepts a string and then an int for priority. Write that message to a specified file and print a success message. Else, if the choice is to read, you read it from the file. Ask them for a file name and read it from the file. If the file cannot be opened, written to, or read from, display an error message. So, just use this class, the JMessage class. You can just copy and paste it. I hope there's no syntax errors. If there are, I'm sure you can fix them. So the JMessage is something that's got a priority, and it's got a message, and it's got a message length. And so it's got a constructor where you pass it a string and a priority, and it calculates a message length based on the length of the string. And it's got a toString method, so you can print it. Calling .display will just call toString and print it. And it's got getters and setters for the priority and the message. So you could do this either with the print writer and the scanner, like we did in our first one, or you can do it with the object output stream and object input stream. Here I thought I made it mandatory. You get to pick. And then there's, I tend to go on too far. You could add a method called write_JMessage file that took the file name and an object, or you could add a read file one that would create that object and return it, but that's just a suggestion. You don't have to implement these inside methods. Stretch goal. Modify the program to read an entire array list of JMessages. That's extraordinarily easy if you've written it as an object output stream based thingy. So, that makes sense? You're going to have a class called JMessage, which accepts a string of data and a int, and then you're either going to write that out to a file, or you're going to ask for the file name and read it in and print it out. Kind of like our points. Somebody nod. Elaine's nodding. Is this okay, y'all? The exception handling one is so simple that I think that you'll have plenty of time to do this one as well. Exception handling one should be a very, very short project based upon what we've already done. Of course, you have to add exception handling to this one as well to get it to work. All right.